Welcome to Chapter 20, Profit Maximization. Variant assumes that the goal of a firm is profit maximization. And the way we define profit maximization is total revenue. Profit from an accounting sense is total revenue minus total cost. So total revenue would be price, the price at which output is sold, times the units of output that are produced, and total cost would be the dollar amount that's spent on the inputs of production, which, remember, we made the simplifying assumption there were only two, x1 and x2, and this kind of W looking letter is actually the Greek letter omega. So omega 1 is the price of factor 1, omega 2 is the price of factor 2. So what Hal is assuming is that the firm is choosing the level of x1 and x2 to maximize price times the technology or production function minus the expenditures. A few caveats before we run with this. Costs must be opportunity costs and not historical costs. So in other words, it doesn't matter. So what if one of the factors of production is something that was paid for 20 years ago? It doesn't matter what the purchase price of the factor was 20 years ago. What we need to do is we need to evaluate it at its next best use. What is the alternate thing that it could be used for, and the value of it in that process? That would be the opportunity cost. Labor includes proprietor's labor, even if it is unpaid. So my dad was a farmer, a commercial farmer. Dad never wrote himself a check for the labor that he contributed to the farm. But if we were computing Dad's economic profit, we need to evaluate Dad's labor at what he could have earned if he would have worked in his next best alternative. Capital is, of course, a durable good. You think again back to a car manufacturing plant. God willing, a car manufacturing plant lasts for many years. We don't evaluate the price of capital as what it costs to construct it, but what is its rental rate? What could it be leased out at for one calendar year? So the price of capital is the rental rate. Now, you could argue quite reasonably that the current period profit is actually too short of a time horizon. That firms, when they consider how much capital to invest, in particular, since capital is a durable good, they do think about future profit. So if we also want to consider future profit in addition to current profit, future profit has to be discounted to the present. And another problem would be that future profit actually is unknown, right? The future technically is unknown, so we must have both an expectation of future profit and a discounting of it into the present. So I would argue that the stock price actually technically represents, there are two theories of what stock prices represent. One would be the book value of the firm. So if the firm were liquidated and all the assets disposed of, what could be divided among all the shareholders. The other sense in what a stock price represents is you're buying into a stream of future profits. So in that sense, the stock price today is traders' best guess of what the present discounted value of future profits would be. So we could argue that the goal of the firm really is stock price maximization, because stock prices represents the market's expectation of future prices. Now, as an example of this, one of my very favorite examples, particularly when we talk about this in public economics again, are the political prediction markets. So the first political prediction market was the Iowa electronic market, and this is a market that was set up in the late 80s by finance graduate students at the University of Iowa School of Business. a larger and more recent market that is applied to many more situations is PredictIt, and I give the URL here. I'd encourage you to look at PredictIt. It's absolutely fascinating. So to give an example from the past, now obviously this occurred in the past, so we all know what the outcome of the 2020 presidential election was. But think about back in January of 2020, how much should a stock trade for that would pay $1 if the Republicans won the White House in 2020? So as of January 1st, so that was 11 months before the presidential election, if this stock were to pay $1 if the Republicans win and $0 if the Republicans don't win, how much should this stock trade for? Well, I claim that what we should do is we should compute the expected value of this stock. So there are two different states of the world. State 1 would be if the Republicans won. State 2 would be if the Republicans didn't win. And let P be the probability that Republicans won in 2020. So the expected value of this stock as of January 1st would be, you would take each possible outcome and weight it by its probability of occurrence. So if P is the probability that Republicans win, we take the payoff if Republicans win, which is $1, multiply it by its probability of occurrence, and if P is the probability that Republicans win, 1 minus P is the probability that Republicans lose. So 1 minus P times 0, because the stock would be worthless if the Republicans didn't win. You simplify the math, the expected value of this stock is the market's best guess that Republicans win. Or what you could say is all the people interacting in the marketplace bring with them some guess of how likely it was that the Republicans were to win the presidential election. So here is what trading looked like. I did a capture, and so here we have the price both of Democrat stock and of Republican stock. And you can see that from the beginning of trading, which appears to be February 7th of 2019, the market was expecting the Democrats to win. So the Iowa electronic market never did predict Donald Trump to win re-election. So there was always somewhat of a gap. And you think about these prices. So let's say that, I don't know. How about right in the middle? So that would be right about January 1st, 2020, that you were absolutely certain that the Democrats were going to win. And the stock was trading at, it looks like, just about 60 cents. So you thought it was a surefire thing that the Democrats were going to win in 2020. You should have gone into the Iowa electronic markets and bought Democrat stock. And then after you bought Democrat stock, you should talk to all your friends. You should have talked to them and said, hey, I know a way of almost doubling your money easy, and talked all of your friends into buying Democrat stock. So as more and more people buy Democrat stock, what would happen to the value of Democrat stock? Goes up, right? It would continue to go up until the price of Democrat stock basically represented the collective judgment of all the market participants of the likelihood that the Democrats were to win in 2020. Right? This is the sense in which prices in microeconomic markets transmit information. In fact, decades back, intermediate micro was called price theory. So this was the story of price theory. Prices transmit information. They transmit information in the marketplace of what consumers value goods at, they transmit information as to what the marginal cost of production of additional units of good are. Okay? So anyway, I'm getting way afield, but I'm excited about preaching the virtues of price theory. All this to say that in the real world, I would argue that a reasonable firm's goal should be to maximize its stock price, since the stock price represents the present discounted value of future expected profits. But we could argue that the goal of maximizing current profits is a reasonable approximation that will be mathematically much more simple. So, as before, we'll make simplifying assumptions just to make the math easier and be happy about it. So, in the short run, at least one factor of production is fixed, and we assume that's capital. So let me illustrate that with mathematical notation that the level of capital is fixed at some level k bar. Okay? So then if our firm by assumption has two factors of production, capital and labor, capital's fixed at k bar, then the question we need to ask ourselves is what level of labor input maximizes profit? And that's, this is a calculus-based economics course. What we should do is we should differentiate profit with respect to labor. Very straightforward. Right? So if we take our profit expression from the very beginning of this lecture, profit is price times the production function minus the cost of labor minus the cost of capital, and I take the partial of that with respect to labor and set it equal to 0, that should define for me the profit maximizing quantity of labor. Okay, so I can rearrange this and I get something very, very interesting. I get omega on the left-hand side, and remember omega is the wage. That is, in essence, the factor price of an hour of labor input. And on the right-hand side, I have the price of output, and then I have the marginal product of labor. So what this tells me then is that the cost of hiring an additional hour's worth of labor, that's the wage, should be equal to the marginal revenue product of that labor. So in other words, if the firm hired an additional hour of labor, the number of units of output that they produce would be given by the partial of F with respect to L. That says how many units of output did the firm manufacture with one more unit of labor. We multiply those units of output by the price at which they're sold, and we get the revenue the firm generates. So profit maximizing behavior is that the firm should choose the level of labor input where the cost of another unit of labor input is equal to the benefit of employing another hour of labor. Quite intuitive and sensible. So, since this defined the profit maximizing quantity of labor, which by assumption is factor 1, what we can do now is we can rearrange this equation to solve for x1. Right? So if I took the partial of profit with respect to x1, set it equal to 0, what that says is I chose the level of factor 1 to maximize profit. That defines the proper profit maximizing quantity of x1. So as an example, I have here a simple production function. F of labor is equal to 10L to the 0.5. If I apply my math from the previous slide, that the marginal revenue product of labor is equal to the price of labor, I put in the marginal product, and what I get now through rearrangement is that the quantity of labor the firm should purchase is 25 times the price of output divided by the wage rate squared. That is now what we would call factor demand. How much labor does the firm want to purchase to maximize profits? We could graph this, right? So we have the quantity of labor on the horizontal output. We have level of output on the vertical axis, and we can plot our production function. Now, Varian defines this thing which he calls an isoprofit line. So iso meaning same. So these would be different combinations of input and output that generated the same amount of profit. So let's say that when the firm is choosing its maximum amount, they've maximized profit, that they have some profit level. And let's say that pi is equal to $1 million. So this idea of an isoprofit line would be all combinations of input and output that would generate $1 million worth of profit, whether they're technologically feasible or not. Okay? And we get these isoprofit lines. So I've repeated the equation from the previous slide. At labor input L star, that's the profit maximizing labor input, you'll notice that the isoprofit line, so the slope of it is given by omega divided by P. It is just tangent with the production function. What we would say then is that the geometry of profit maximization is that the firm chooses the level of labor input where the production function is just tangent with the isoprofit line. So the slopes of those two are equal. That defines L star. It's technologically feasible to get lower profits, but higher profits. So in other words, higher lines represent more profit. More profit is better, but it may not be technologically feasible. Okay. Now, consider what would happen if wage increased to $15 an hour. So if the slope of the isoprofit line was the wage divided by the price of output, suppose that wage prior was $10 an hour, it gets bumped up to $15 an hour. What that does is it makes the slope of the isoprofit line steeper. So the net effect of that is that the tangency now with the production function will occur at a smaller level of labor input. So in other words, if the minimum wage were increased, the quantity of labor that would be purchased by perfectly competitive firms would decrease. Okay. Now, you might remember back in Chapter 7, we introduced the idea of revealed preference. Well, now we have revealed profitability. So this will be a cousin of revealed preference. And you recall in this chapter, what we've done up to this point is we've assumed we know what the production function is, and then we calculate the profit maximizing quantity of input. So imagine Warren Buffett, the famous stock picker financier. So Warren Buffett very famously goes through companies' quarterly and annual reports with a fine-tooth comb where they disclose how much of inputs they have, their various expenditures, output levels. So imagine Warren Buffett is looking at the annual report of a firm, and Buffett can observe what inputs are used. He can identify what outputs are produced. He knows what the costs of inputs are. He knows what the price of output is. Buffett can therefore estimate, well, he can basically draw each one of these isoprofit lines. Now, if the firm really was maximizing profits, if the firm was well run, what we should have then is that the input-output combinations that were chosen by the firm are the ones that maximize profit. So, and the net effect of this then is that each one of these isoprofit lines put together, you get this diagram as exists to my left. that forms a upper bound of the possible productions, the production set. The weak axiom of profit maximization, or WAPM, remember we had warp in chapter 7, now in chapter 21 we have WAPM. The weak axiom of profit maximization expressed mathematically is delta P delta Y minus delta omega delta L is greater than or equal to 0. Okay. So on the far left, you have a diagram in which we observe the firm in 3 different time periods, input-output combinations. We're able to observe prices, right? So when the first set of prices was in effect, the steep isoprofit line, you'll notice that the other 2 input-output combinations lie beneath it. So what that means is those other 2 input-output combinations would have generated less profit than the profit that was generated by the point that the firm chose. The middle point. Again, what we could argue here is that either the price of output increased or the price of labor, the wage rate, decreased. What that did is it caused the slope of the isoprofit line to flatten out. And now, under those circumstances, the middle production point, input-output combinations, generates more profit than the first one or the third one. And as that process continues, finally, when output either becomes really expensive or inputs become really cheap, the isoprofit line becomes flat. This production process where I use a whole bunch of input to generate slightly more output generates more profit than either of the previous 2 production points. You'll notice that the second diagram violates WAPM. And the reason why, I can say that the rightmost combination, right? So that was the input-output combination when the isoprofit line had the middle slope. As we get to the flattest isoprofit line, you'll notice that we have this point where the flattest isoprofit line is tangent to the steepest isoprofit line. That point is above the point chosen for the medium slope isoprofit line. What that implies then is that there was a different technologically feasible input-output combination that would have generated more profit than the point that was chosen by the firm. So this firm in the rightmost column, to my immediate left, was not consistently maximizing profits. So this would be a firm that would be a possible target for a takeover, a hostile takeover from the sort of companies that buy out poorly run corporations, fire the management, and then reorganize them. Right. So as an example, this is one of my favorite real-life examples. My previous job, prior to coming to Baylor, I was a professor at the Air Force Academy. And the Air Force Academy, the cadets are in this secure area. So you have to have a government ID, and you have to go through multiple security layers, go through 2 layers of guards with machine guns. And then I had my ID that I would swipe to get through a cyber lock, and then you were in the cadet area. So the Academy only allowed one coffee shop in the cadet area, and it was Trina's Brewed Awakenings. So Trina's a real person. So consider Trina, and we have Trina's input and output combinations in 2 time periods. So we have the price of lattes, the number of lattes that Trina brews, and then the price of labor and how many hours of labor that Trina uses in her shop. suppose that the price of lattes increased and the $15 minimum wage came, and Trina had to increase the pay of her worker from $10 an hour to $15 an hour. So if we want to see whether Trina fulfills WAPM, so the change in the price, prices go up by 25 cents, right? Her output increased by 20, wages went up by $5, and she employed more labor. Okay, so as I multiply it all out, delta P delta Y minus delta omega delta L is negative 20, which is not greater than or equal to 0. So Trina violates WAPM. We could also make a matrix much like we did with warp. So in this case, we have the rows representing price combinations, so the price of lattes and the price of labor, and then the columns represent input-output production plans. So what I've done is I've computed the amount of profit that Trina could have earned in each time period by using the input-output production plan. So you can see that, and of course the diagonal represents the input-output plan that Trina actually used. You can see that in the first time period, Trina would have actually made more money if she would have used her second period production plan than the one that she actually used. So Trina left money on the table. She violated WAPM, right? So, yeah. Quiz. So let us have a production function, 6L to the 2/3. We have a cost of labor, a price of output. How many units of labor will the firm hire? Well, we can use our favorite profit maximizing input formula that derives several slides back. So we have on the left-hand side the marginal revenue product of labor. This is the value of the increased output that you would get from hiring one more unit of labor. On the right-hand side, we have the wage rate, which would be the cost of hiring one more unit of labor. So I take the derivatives and I manipulate and solve for L, right? So, so now it turns out I have to cube both sides, and L, the quantity of labor that this firm uses to maximize profit, should be 27 units of labor. So that does it for chapter 21.